Hello everyone and welcome back. Today we're going to be taking a look at some other data types. In the previous video we covered strings, which are just a fancy way of saying it's a sequence of characters. Tim's a sequence of characters, Apple is a sequence of characters, Apple 2486 test case is a sequence of characters because it's all inside of quotation marks. And of course we could have this in each of these and it'll work just fine. If we click play, we can see all of that prints out down here, or it appears down here. We're just going to use the word prints just because it's sort of how I think about what it's doing. But either way, this is effectively what we covered. In this video, I want to take a look at some other types. So these are, of course, words. Now, we did have some numbers that appeared here, but let's go ahead and let's take a look at some numbers. So to get started, we can think of this the way we would in, I don't know, our math class. We could say x is equal to 1. We could say y is equal to 2. And then we could do something like puts x plus y, just like before. Now at this point, I want you to stop for a second and think about what this might do. So in the case of like our first name and our last name, it would do something like we had, 1 plus 2 would be equal to 1 with 2 next to it. If we put like a space next to it, maybe that would give us 1 space 2. But of course, there's the other way of thinking about this, which is like the literal mathematical way of thinking about it, which is that 1 plus 2 will give us 3. I just want you to keep that thought in the back of your mind. We click play and we can see 3 appears down here. If we run it over here, same way we did before with the Ruby main.rb, we can see 3 appears over here as well. So what's the difference here? Well, effectively, when we don't have these numbers inside of quotation marks, like if we had it like this, it then says these are actual numbers, which means when we do a plus, we need to actually do addition. We won't just do what we did previously, which is like gluing the two things together. So in this case, if we were to then take this and put both of these inside of quotation marks, just like we had before, if we run this, you'll now see we get that 12. Why? Well, because now it's treating this almost like just two different words that it's putting together, or two different sequence of characters, where each character is like one number, one letter, etc. So now it's saying, well, we have x plus y, but they're both inside of quotes. So they probably don't want us to like add up these numbers. Instead, they just want us to put the numbers next to each other. So that's where we're now getting 12 from. There's other ways to do this. There's other ways to think about it, but that's usually the way that I like to think about it is when there's no quotes, it's just literal arithmetic. And when there are quotes, you're kind of just gluing things together. So that's fine. But now the question becomes, okay, just like before, how could we do some more with this when we print it out? Maybe we want to be more clear about what we're printing out. So let's go ahead and let's try that. If we were to, inside of quotation marks, just puts x plus y, we can do this, and we'll now see that we're literally just getting x plus y. Why is that? Well, because again, it's treating this just like a sequence of characters where it's like, all right, you want me to literally put on the screen x, then a space, then a plus symbol, then a space, and then a y, right? We could do this in another way. We could do like t plus z, which don't exist up here. If we run this, you'll see, well, nothing right now. If we run this again, you'll see t plus z appears. I don't know what happened there. That's because in this case, it's just treating these like actual characters. But what you can probably assume is if we try to actually print out t plus z with the arithmetic intent behind it, we don't have a t, we don't have a z. This is probably gonna, you guessed it, throw an undefined variable error, which is just saying, hey, t doesn't exist. We can do the same thing over here. We can see undefined local variable error method t for whatever, who cares. So in that case, we probably want to stick to x plus y. But let's do what we did before. Let's say maybe we have like that x plus y, and then we want to say this is equal to plus, and then we could do something like x plus y right here. So we could do x plus y. Now, what do you think will happen here? Because now we have the literal symbols, and then we have the arithmetic symbols over here. So this could either be x plus y equals plus x plus y, or this could be x plus y equals 3, or it could be x plus y equals 1 plus 2. Who knows? Let's go ahead and let's try to run this. I'm actually going to run it over here so it's a bit more readable. And now we can see no implicit conversion of integer into string. And this is something you'll see in plenty of other programming languages to some degree. Basically what happens is under the hood, we say each one of these data types, whether it's first name of type string, or it's a number of type integer, or we call it a decimal or a float or whatever. The thing that the programming language usually doesn't like to do is like this implied version or this implied way of doing things. That's why it says no implicit conversion. What it means by implicit is it's assuming that you want it to figure out what to do here. Whether that should be to literally put the symbols on the screen, or to do the arithmetic, or to put these symbols on the screen and then do the arithmetic and then attach it to this string. So in this case, what it wants you to do is to put everything in the same type. What that might mean is either putting everything into strings or putting everything into numbers. Now, if we look at this, because we want it to print out literally x plus y equals, and then whatever we want over here, we probably can't convert this into a number. So we have to take this and turn it into a string just like these. If we put the quotes around this, that won't quite work. Like we could do something like this, press play, we can see x plus y equals x plus y, which although mathematically that's true, that's really not going to do a lot for us in this case. So instead what we can do, in some languages, like I think Python is going to let you do something like convert this to a string by doing str around each of these variables, which will then convert it into a string. For me, that's fine. But if we try to run this, we're not working in Python, right? And there's like other ways to do it in other languages because every language has to somehow deal with this problem. In the case of Ruby, the way we deal with this is we can just do a .to_s, which you can think of as just .toString. Why we use a dot there, that'll come a bit later when we talk about objects and classes. But basically, everything in Ruby is considered an object. Every object has some things that are helpful with it that allow you to turn it into something else. In this case, numbers have a helper that that help you to turn the number into a string in a way that then lets you print it out. Now we can do that to each of these. Unfortunately, this is really annoying to do because it's like, why do I have to do this? And also I have to type this every time. And then also when I go to run this, I get 12 back, which isn't what we wanted, right? What we were thinking we wanted was what, like 3? So how do we get to that 3 instead of this 12? Well, first, let's just go ahead and let's copy this line, paste it right here. And then let's take this first line and hit Control and the question mark again to comment it out. Or we could just put a shift 3 pound hashtag, whatever symbol you want to call it here, to comment out this line. So instead, what we could try to do is we could maybe do what we did before with the full name, right? If we come back up here to episode 2, we had the full name equal to the first name plus the space plus the last name. So maybe here we say z is equal to x plus y, just using basic arithmetic. And then down here, we could just say plus z dot to string. If we do this now and we run it, you'll see over here x plus y is equal to 3 because we have the literal symbols x space y space, x space plus space y space equals space. We want to put all of these on the screen, which is what this section right here is, plus z, which is just x plus y, which is just 1 plus 2. So we're saying z is 3, but we need this to be of type integer so that it doesn't have to implicitly convert it to whatever we need it to be. And then we say, all right, it's of type integer, so let's turn it into a string so that we know 100% certain this is a string, so we can just put 3 after whatever this is, which is how we get the x plus y equals 3. The other thing we could do here is we could say, well, maybe we don't want to do it like that. Let's do x plus y dot 2s. And I'm actually going to copy this, undo it real quick, just so that we can keep this version right here. And then we'll do it like this instead. Let's change the numbers. Maybe we'll do 2 and 3. So this should now be 5. And we don't actually need the Z here. So let's just comment this out. And let's also comment out this first name because it's bothering me. So now let's go ahead and let's try to run this again. And now we get x plus y equals, which again is coming from what's inside of the quotes, which is just literally these symbols, plus whatever's inside these parentheses, just like we're back in, algebra, PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction, I think is how they describe that, although it's not technically how they want you to think about it now, but whatever. Same idea, we're just doing order of operations. X plus y gives us 5. We then take 5, convert it to a string, and then we add the string 5 to the string x plus y equals, and that gives us x plus y equals 5. Now there's other ways to do this, right? We don't just have to be limited to either, strings or integers. Maybe we have something like x is, 2.4 and y is 3.5. What do you think will happen now? We can press play. We can see x plus y is equal to 5.9. This is where we run into what's called a floating point number in a lot of languages. It's also called a decimal in some. Obviously, we have actual words we can use to describe it. These are going to be a little bit more confusing when you try to use them. And that's just because there's only so many decimal places that the languages will support. So if you have something like this plus something like this, sometimes this is like too many decimal places, and then you're going to run into a rounding error, and your result is just going to look like this, even though technically you have like some number over here. And if you do enough addition like this, you can run into some floating point number shenanigans where the number you get back got rounded in a weird way at some point, and now you're getting a different number than what you expect. So always be careful when you're using these. We'll of course cover these more in the future, but for now I just want you to be aware of the fact that you can use decimal numbers. You can also use negative numbers. So we could say negative 2.4 plus 3.5. Let me get rid of some of these zeros so we can at least read this. And now if we run this, we can see x plus y equals 1.1 because 2.4 from 3.5 is 1.1, right? There's other things we could, of course, do here, but for this one, I really just wanted to focus on numbers. We'll worry about a couple of the other ones in the future videos, just because those will be geared towards different topics where we might use them. These are just kind of the ones that you should worry about right now, which is just, your basic number and then your decimal numbers, and you also have the ability to have negative numbers, etc. And then you just have various ways of printing these out if you're so inclined. But for now, that's going to do it for this one. Thank you so much for watching, and hopefully I will see you in the next one.